Yes, good morning children. Now, today we are going to study about our next topic, that means in coordination compound. Now we are going to study different types of theories. In this section, I would like to explain to you about the Warner's theory of coordination compound. Warner was the first scientist who have attempted to find out the actual bonding in coordination compound. He made an attempt by combining cobalt chloride with ammonia, and he has found the different types of complexes, different ways of combining of this cobalt chloride with ammonia, and different complex compound with the ways which he has framed has given different colors. And along with that, when he had mixed this silver nitrate within this complex, he was able to remove the precipitate has been formed in the form of silver chloride. Okay, so we will discuss this point in one at a time. The four types of complexes which he has framed, I have written everything on the board so that it becomes easy for me to explain and for you to understand. The compound which Warner framed was cobalt chloride, that is COCl3, first with 6 molecules of ammonia. This was the compound given by Warner first. This compound shows yellow color. The color of this compound was yellow. And the number of moles of silver chloride that has been obtained when this complex compound was treated with silver nitrate. The 3 chlorine that is present here was reacted with silver nitrate and precipitate silver chloride. That is 3 moles of silver chloride was formed. And then the complex that is formed after formation of the removal of this 3 chloride ion, the complex form was CO, that is a cobalt, and the 6 molecules of ammonia then get attached to it in the form of a ligand. We have already talked about ligand, so this you will be able to understand. 6 molecules of this ligand will be there, and this complex square bracket has been closed, and this attains a positive charge. That means this is acting as a cation. And here the 3 chloride which is present, this 3 chlorine which was present here has been precipitated, that has been written here. It is Cl3 with a negative charge. That means this 3 chlorine has come out of the complex and have reacted with silver nitrate and obtained. Now last column you see the number of ions. Now total number of ions that is present in this complex is 3 chloride ions and 1 with that of this complex. That is total 4 number of ions is present in this complex. Now you see the second compound which he obtained. He saw that COCl3 again with 5 molecules of ammonia in it. Okay, this is the second complex which shows purple color. Color of this complex was different because of differences in only 1 molecule of ammonia. The color changed, and the total number of moles of silver chloride that has been precipitated was found to be 2. Now you can see why it happened. Why only 2 molecules, in spite of having 3 chlorine in there in the compound, still then only 2 chlorides has precipitated in the form of silver chloride. Now how this happened? This has completed its central metal atom has completed its ligand attachment. See, only 5 ammonium molecules were there, and 1 of the chloride from here has entered from the counter ion. It has entered into the complex. It is no more in the form of a counter ion. It has entered into the complex sphere. Now you can see that this is the complex sphere which has been formed. Now only 2 chloride ions were available for silver nitrate to precipitate in the form of silver chloride. So now you will see how many number of ions that you can see. 2 chloride ions here and 1 is the complex ion. Total is 3 ions are present here. Next you see here also the third one, COCl3.4H, 4 ammonia. Now another complex has been obtained, another compound which he has obtained was having 4 ammonia. When there was 4 ammonia present, he found that the color of the compound was violet. Okay, the color of the compound changed. You will notice here that afterwards I will tell you one thing. And the number of moles that is of silver nitrate obtained was 1. As because only 4 ammonia, 2 chloride ions has entered from the counter ions place to that of the complex. So you can see the 2 chloride ions here. The 4 ammonia is acting as a ligand and 2 chlorine came inside. And only 1 chloride ion was left behind. So now total number of ions present here will be 1 with this chloride ion and 1 with this complex ion. So total will be 2. Now in the fourth case also you see one more very interesting thing, children. This 2 formula is same. You can see here also 3 chloride with 4 ammonia ions. But the color of this complex is found to be different. Have you seen the color? The color is different. It is not matching. The same color is not there. But every content is same. Complex formed is also same. Number of moles of silver chloride came. Precipitate is also same. Number of ion is also same. What is the difference? Why the color of these 2 complex compound obtained is different? It is because the arrangement. It is geometrical arrangement of these 2 complexes, that is cis and trans. If with cis it is forming one color and with the trans it is forming the another color. It is only that due to this geometry this color has changed. Now further we will study about the valencies. What Warner did about the valencies of this compound. Warner was the scientist who had come across and given the valencies of 2 types in coordination compounds. Okay, in coordination compound what he said, there is a one primary valency and another is a secondary valency. This we have talked earlier also, but once again I will tell. What is the primary valency? It is that valency which is having the attained by the central metal atom also, and normal valency which helps to frame the coordination compound as a neutral molecule with the counter ions, and the valency you generate with the central metal atom, and that valency is known as that which you write in the parenthesis. These are the primary valencies. Secondary valency which come across is the coordination number which you have studied. Okay, the definition which you have studied, the coordination number. That means the number of ligands which is attached to the central metal atom. That number determines or explains about the secondary valency. So he was also the one who have given this concept of primary and secondary valencies in the coordination compounds. Okay. And children, one more thing to remember and keep it in mind is that these primary valencies are ionizable, they can be ionized, but secondary valencies do not ionize, which we have studied in the very first introduction part also, that secondary valencies do not give the elements or metals or ions which is present in them, do not give its test. When performing the test, they are the part of the complex compound. And another part that you have to understand here is the secondary valencies is responsible to give the proper structure or frame of the complex compound. Okay, the complex compound which have a geometry, or you can say the structure, it is attained only with the help of these ligands. As you know, we have talked about the ligands. Ligands are those substances which give its electron by the coordination bond to the central metal atom. So here Warner also has given its complex compounds some structure he has framed, which we will see very nicely in this video. Now children, I have drawn some of the structures on the board which was given of the complex compounds, okay, given by Warner. We will try to understand these structures, why these structures has framed in such a way and what we wanted to explain. In this first structure, you see cobalt having hexamine group attached to it and 3 chloride ions are written outside the square bracket. These 3 chloride ions are the counter ions. When it is dissolved or the reaction is taking place with silver nitrate, these 3 chloride ions were giving the precipitate in the form of silver chloride. But the structure that they have written here is such: cobalt is there in the central metal atom and the 6 ammonia has been attached with the help of a strong bond That is, you can see the single bond, strong bond, the boldly with that has been written here. And this is the structure that has been framed by this compound. And that means if you will frame this in this way, you will find that it is having octahedral structure like that. Okay. So, and the rest three, you can see the 3 chlorine that is was here counter ions has been also written here, but with a dotted line. This dotted line indicates that these are the ionizable. They can be ionized. They can be removed. Okay. See the second structure, it is here. Cobalt with 1 chlorine and ammonia, 5 ammonia. That means one counter ion has entered into the complex. Now this counter ions which has entered into the complex is now no more counter ion. That is no more ionizable. It will not at all give its precipitate. Now it has entered into the complex entirety. Okay. Now here you can see the structure again. Cobalt is there with 5 ammonia. 1, 2, 3, 4, 5. 5 ammonia and the 1 chlorine which has entered into this complex has also attained a strong bond. And dotted line in strong bond is written as to show that this was first ionizable and then it entered the complex. Now it is no more ionizable. Now it is entered in the complex. And this symmetry and other 2 chloride ion with the dotted line, that these 2 are ionizable forms of precipitate with silver nitrate. And then it indicates the geometry complete. Okay. Now you see the next structure. In this next structure also you see 2 chloride ion has entered into the complex. So you can see these 2 chloride ions which has entered into the complex. I think you will not may be able to see this properly if I will hold this. See children, these 2 chloride ions has attained the stability, its structure. Now and the third one which was ionizable has been written here with the dotted line. You will find in all these structures you have not overlapped the things. It has been completely done very clearly with a proper this geometry has been attained with the difference in the this thing not overlapping or some position has been cleared here. Here also you can see all the 3 ionizable has entered into the complex now. No more ionizable and this has attained the geometry what has been originally framed. Now total geometry along with the ammonia, that is as well as chloride ion has, and now the neutral compound has been obtained. No more counter ion is present here. This complex is also known as neutral complex and the geometry is similar to that, and then geometry has not been changed. So this is the way Warner wanted to explain the structure and the arrangement geometry of the complex compound, in which only the complex ions is responsible to give its geometry. So that you will be able to understand this as I have. Yes children, apart from this there were some limitations of Warner's theory. There were 3 limitations. First limitation is that why only Warner was able to do this reaction, this all explanation was given by only one type of complex. He was not able to attain such explanation, he could not give the explanation or could not do the reaction with another type of complex compounds. Second thing is that he was not able to explain about the magnetic and optical properties of these complex compounds. And one more is there that this complex compound has the coordination, and why this only complex gives the geometry, not the whole compound, only the complex entity is giving the geometry. With these 3 questions could not be answered by Warner. Okay, and for that new theories came forward, that is valence bond theory and crystal field theories. There are many other theories which we don't have to study in this section. You have to study only about the valence bond theory and crystal field theory, which will help you to overcome the doubts given by Warner. And that I will show you or explain you in my next video. Thank you children.